Hi everyone, welcome to the video. Here in this video I will be discussing semester 1 engineering mathematics, that is linear algebra and calculus, starting with the module 1, that is linear algebra. Let me introduce what is linear algebra. Linear algebra, it is a branch of mathematics dealing with linear equations and representations in vector spaces and through matrices. It is a basic subject on matrix theory. Linear algebra is a study of set of all equations and their transformation properties. Metrics and determinants are extremely useful tools for the linear algebra. You have already studied metrics in your higher secondary section, isn't it? Here in this module, we can learn how to solve a set of equations using matrices and matrix method. Moving to the module 1, that is linear algebra. Let's start. First of all, linear system of equations. What is linear system of equations? We all are familiar with equations, right? Let's see what is a system of equation. A linear system of m equations in n unknowns, that is x1, x2, etc. xn. It's a set of equations of the form like this: a11x1 plus a12x2 plus etc. plus a1n xn equal to b1, a21x1 plus a22x2 plus etc. plus a2n xn equal to b2, etc. a m1x1 plus a m2x2 plus etc. plus a mn xn equal to bm. This consists of m equations and n unknowns. The unknowns are x1, x2, etc. xn. Here the numbers a11, a12, etc. am1, am2, etc. amn, that are the coefficients of x1, x2, etc. xn. That is, they are the coefficients of the system of equations. And x1, x2, etc. xn are variables. And here on the right hand side we have b1, b2, etc. bm. That is, they are also numbers. Okay, so this consists a linear system of equations, that is m equations in n unknowns. If all the bj are 0, that is the numbers which are in the right hand side of the equation, then the above system is called homogeneous linear system of equations. If the bj is not 0, all the bj is not 0, then the system is called non-homogeneous linear system of equations. Then a solution of the above system is a set of numbers x1, x2, etc. xn that satisfies all the m equations. To solve the system of equations means we want to find the values for x1, x2, etc. xn which satisfies all the given equations. If the system is homogeneous, that means if all the bj's are 0, then the system has at least the trivial solution, that is x1, x2, etc. all the variables are is equal to 0. That means the trivial solution. So these are the basic terms which are related to the system of equations. Matrix form of linear system. We can convert the given linear system of equations in a matrix form. Let's see. This is the system of equations, that is m equations in n unknowns. First of all, write the coefficients of x1, x2, etc. xn in a matrix model. That is a11, a12, etc. a1n. That is in the first row. Second row will be a21, a22, etc. a2n, and the mth row will be a1, m, etc. amn. That is the first matrix. Then write the matrix corresponding to the variables. Here there are n variables. So write it as a column model, that is column matrix x1, x2, etc. xn. So these are appearing in the left side of the equation. Okay, then equal to. Next, in the right side of the equation we have b1, b2, etc. bm. Write in a column matrix, that is b1, b2, etc. bm. So this is the matrix form of the linear system of equation. Here the coefficient matrix is denoted by capital A and the variable matrix is denoted by capital X, and b1, b2, etc. bm is denoted by capital B. So this matrix form will be rewritten as capital AX equal to B. So this is the matrix form of the given linear system of equations. Next, augmented matrix. What is an augmented matrix? If the matrix form corresponds to the linear system of equations is this one, that is a1, a2, etc. a1n, am1, etc. amn, then x1, x2, etc. xn, that is equal to b1, b2, etc. bm, that is ax equal to b. Then the matrix a11, etc. a1n, b1, a21, a22, etc. a2n, b2, etc. am1, am2, etc. amn, bm is called the augmented matrix of the linear system of equations, that is a matrix with the elements from the coefficient matrix and from b1, b2, etc. bm. This matrix corresponds a augmented matrix. It is denoted by matrix AB. Let's see an example. Consider the linear system of equation. This is our linear system of equation, that is 3 equations with 3 unknown variables. Okay, first of all write the matrix form. So we get 5, 2, 1, 2, 6, 2, 1, minus 1, 3. Then x, y, z is equal to 1, 0, 3. Therefore, the augmented matrix is a matrix with elements A and B. So here matrix A, that is 5, 2, 1, 2, 6, 2, 1, minus 1, 3 along with the elements of B, that is 1, 0, 3. Therefore here the augmented matrix is 5, 2, 1, 1, 2, 6, 2, 0, 1, minus 1, 3,